This is a science live session. My name is Amy Defoe. I'm one of the science teachers here at Graduation Alliance. Thanks for joining today. Today we're going to be talking about some earth science. We're going to be looking at the unit on weather. And we'll also be talking about how to upload, how to download a document and how to upload a document to the Dropbox so that you can submit. There's a couple assignments I know in science that ask you to do that. And so I wanted to make sure we'll go over that. And we'll go over the one that has to do with the Coriolis effect. Of course, in this live session, we've also had time scheduled in so that if you have questions about a topic or an assignment that you want to go over, we can get that done for you during this time. Before we get started, a couple things. These sessions are being recorded as it's being recorded right now, and we do this for lots of reasons. Biggest reason is, of course, so that you can view this whenever you want to. We know that, things are happening and you got responsibilities and you have life and you can't always meet the timings on these live sessions. So they're recorded so that you can view it at a time that works better for you. So after these sessions are complete, recorded, a link is sent out, and then you can go to that link, which we do have the whole Teacher YouTube channel where you can see all of the different live sessions throughout all the different courses here at GA. Pretty cool, because now we have this nice library created for you guys so that you can see these live sessions every day, every week that they come in, new ones are added, and you can go to those and you can view them when it works for you. And we know that sometimes you're not at the particular spot, maybe in a lesson that we're talking about today. Maybe you're not right there at weather, but maybe in a couple of weeks you're going to be there. And so you've got that in the back of your mind to think like, oh, that's right. I could go to the YouTube channel and I can see these live sessions and I can go back and I can get a little bit more help, or I can get a little example of how to do that assignment. So pretty cool to think about. Also, with these live sessions, we do encourage, and I love it, student interaction. So we know that we're, an online school, but we still have this community. We still have, our teachers and our classmates, and we still have our academic coaches and our local advocates, everybody here to help us and help you succeed. So during these sessions, if you have questions, if you see something on the screen that looks pretty cool, say so. If you want to give your feedback and answer questions, because I'm going to ask them, I appreciate that. I'd love to make that connection and interact with you all. So going off of that, you have the option with this Zoom is that you can mute yourself and you can unmute yourself. So if you want to talk, make sure that you are unmuted so that we can hear you. But of course, if you have some background noise going on, you can, of course, mute yourself so that doesn't come through to everybody else. Same thing with your video. You can choose to show, you can choose to take that off. Whatever your comfort level is, works. And the last thing is there is a chat function. So there's a chat box. So instead of, if you don't want to talk out, or if you want to give a response, go ahead and type it out. Whatever mode of communication works for you, works for me. Sounds good. Okay, well, let's go ahead and get started. So cool little picture there. You can see kind of showing a picture from out in space looking down upon the Earth, and there you can see some continents. You can see North America, and you can also see we're looking at some oceans, but wow, you can see all those clouds. We're going to be looking and talking about weather patterns today. So let's take a look at what this agenda looks like for us. So like I said, we're going to be talking about earth science, and we're looking at semester 2. We're going to look at weather patterns, which comes from Unit 5. I'll talk a little bit about weather patterns, and then I'll open up to that first question and answer series. And again, you can ask questions about weather, what we just talked about, or wherever it is that you're at in science and whatever course in science that you are in. Our skill today is we'll be looking at downloading and uploading a document, specifically looking at activity 521, Coriolis Effect, as our example. And then before we end today, we'll have another question and answer period for you. Make sure that you're set to go over the weekend in science. Okay, here we go, guys. What is weather? Sorry about the little picture. I really like this picture because it kind of gives a nice comparison, but sometimes they don't come up as nice as I'd like them to be. So what is weather? When you think about what's the weather report, or somebody says, what's the weather like outside today? how do you describe that to somebody? I know most of the time we could say, oh, kind of cloudy, no, partly cloudy, there's some blue sky, or we say it's cold, it's raining. You know, sometimes we usually kind of describe like the condition, what's happening out there. And that's pretty much what we describe science as. It's the condition of the atmosphere at a particular time and place. So we add a little bit more detail in there. So we're talking about, you know, thinking about what sphere weather is occurring on Earth. So when we're talking about the spheres, we have, you know, the hydrosphere with water. We have the biosphere, thinking of all the living life on Earth. And we have the lithosphere, which is the surface of the Earth. And then we think of the atmosphere, and that's the outside of the Earth, that nice protective layer of the Earth filled with gases. And of course, this is where weather takes place, okay? Biggest thing about weather, though, it's at a particular time and a place, okay? So it's specific. We're not talking about a long range. We're talking about a particular time. So, you know, whatever day and time it is, and a place, because we know that weather is different all over the Earth. Lots of times weather and climates get confused. People will say, well, what's climate? And people say, oh, it's the weather. But it's different. It's actually, we can see a little comparison, climate versus weather. Climate, is an established pattern of weather over a long period of time. So again, with weather, we're talking about this particular time frame on that, like on a particular day. So with climate, again, it's looking at a whole entire range. So it's like looking at like, you know, a year or season of what that weather is typically like. It's kind of like it's averaging out the weather over time. And again, weather, we're talking about the day-to-day variations of the condition of the atmosphere. So we know that it could be snowing one day, or it could be sunny one day, and the next day it's raining. We know that with weather, it changes day to day. It can vary even from hour to hour sometimes. Okay, but again, with climate, we're talking about long ranges. And so you've probably seen these types of images before on maps, where it shows kind of the surface of the Earth, looking at the land masses, the continents here. And usually they'll be like color coded to kind of give you an idea of what type of climate they're having, like a dry, warm climate, you know, a cold climate. Okay. And then again, when we think of weather, we usually see these little weather symbols for, you know, sunny, raining, partly cloudy, that kind of stuff. Okay. What influences the weather? So what makes it either nice or cold or whatever kind of weather it is that you like? I like it when it's sunny like that. So what do you think influences the weather? The air, yeah. Kind of hard to think about that. You know, seasons. What causes the seasons? Let's take a look at that. Well, it kind of has to do with, you know, the position of the Earth. And as we think about the equator, if we think of Earth, and Earth is this giant sphere, so it's like a big ball. We've got poles on each end. The Earth doesn't sit straight up and down. It sits on a tilt. So it's like if you have this ball and you just rotate it 23.5 degrees, that's where Earth is. And so it doesn't sit straight up, rather it sits on this tilt. And we call that, the Earth sits on an axis. So the Earth sits on its axis, which causes it to tilt 23.5 degrees. Places near the equator get more of the sun's direct rays or energy. And this is what causes that season. So we think about, well, why do we have seasons and what causes changes in the weather? It has to do with that tilt. Because if you look here, we've got, you know, the Earth, and this red line right there represents the equator, okay? And as you can see, we've got, you know, the northern hemisphere and we've got the southern hemisphere, okay? Northern and southern, and we've got the sun. And we're thinking about as the Earth is revolving around the sun. So again, the sun is in the middle, the center of our universe, and the planets and the Earth revolve around it, okay? Because of that tilt, we've got certain amounts of the sun's rays that hit certain areas depending on that revolution around the sun. Okay, let's take a look at that a little bit better. Okay, so this is kind of showing the Earth as it revolves around the sun at different time periods. So we've got the December solstice. So again, when we think of solstice and equinox, solstice is going to be either the longest or the shortest day of the year, depending on if you are in the northern hemisphere or the southern hemisphere. So we've got in the northern hemisphere. So if you're in the United States, think about this. In December, we think of as winter here. It's the shortest day of the year, meaning we get the least amount of sunlight and more days that are darker. The opposite is true in the southern hemisphere, so it flip-flops. So whatever weather pattern we're having in whatever season we are in the northern hemisphere, it's opposite in the southern hemisphere, and that's because of that tilt of the Earth on its axis. Okay, so we've got the solstice, and then of course we know in the summertime here, the June summer solstice. When you think about that, it's the longest day of the year because we're getting that's when we get the most amount of this direct sun rays from the sun. And then we've got the equinox, spring and fall equinox. And again, if you look at that prefix, equa, think of equator, equal, equinox, equal day and night. So that's when it is equal, 12 hours of sunlight, 12 hours of darkness, all caused by the Earth rotating towards the sun and spinning away from the sun. Okay, so if we're here in the northern hemisphere and we are revolving around the sun in this pattern, what you'll notice here is that the northern hemisphere is tilted away from the sun. So we're getting less of those sun rays. That's why we have darker days. And whereas if you think the southern hemisphere, they're getting more of that direct sunshine. That's why it's summer there. Okay, and then as we move to the equinox, it becomes more and more equal. And then as we go to the other side over here to that June solstice, you'll notice the northern hemisphere is tilted towards the sun. So we're getting those more of the sun's direct rays, giving us summer, longer days, shorter nights. Opposite goes for the southern hemisphere. They're tilted away. So that's why they're having their winter when we're having our summer. Pretty cool to think about. Okay, so we're talking about things that have an effect on our weather pattern. Okay, so again, that tilt of the Earth causing the sun's direct sunlight and the rays to hit in particular areas, going to have an effect on the weather that we get. But also, the Earth's rotation creates these winds. The Earth's rotation causes wind currents to circulate throughout the atmosphere in specific ways. So as you think about it, if you've got wind currents coming up in the atmosphere, they're going to carry whatever condition is going on in the atmosphere. It's going to carry those currents with it. Okay, and as we think about the rotation, while we're moving west to east or from high pressure to low pressure, air streams also curve in a clockwise rightward motion in the northern hemisphere, and then opposite, air streams move in a counterclockwise motion in the southern hemisphere. And this is what we're talking about with the Coriolis effect, okay? So as we're thinking about these rotations, and they're carrying that wind current, and it has to do with pressure, temperature, causing these wind currents to move and carry that weather with it. Okay. Again, as we talked about in the northern hemisphere, our weather patterns have a tendency to move clockwise. In the southern hemisphere, it's opposite, so it's counterclockwise. Okay. The Earth's rotation causes wind currents to circulate throughout the atmosphere in specific ways. Now, this movement is called the Coriolis Effect. And the Coriolis Effect causes the wind in the northern hemisphere, like we said, to curve clockwise up to the right as a result of the Earth's rotation, and counterclockwise in the southern hemisphere. And we can see that the currents swirl to the right in the northern hemisphere and left in the southern hemisphere. Okay, so here's a simple picture taking a look at here. So we've got the northern hemisphere, we've got the southern hemisphere. Here's our equator. So again, we're turning to the right in that clockwise pattern. So it's going to rise up and it's going to come down. And of course, temperature has something to do with that high and low pressure. Opposite occurs in the southern hemisphere. We go in opposite directions. And this just shows a whole lot more of those currents going on. Okay. So why would temperature have an effect, or what's making these patterns move in the way that they are? Okay, and that has to do with convection. And we've talked about before, we've heard of convection ovens, we've heard of, convection currents in the Earth's layers inside of the Earth when we're talking about plate tectonics. And convection has to do with the way that heat moves. We know that heat rises. Okay, so a band of clouds forms near the equator as moist, warm air rises. Then dry, cooler air sinks as it moves away from the equator outward towards the north and south poles. This interaction between dry air and moist air makes it clear why so much swirling takes place, okay? So as we think about here, we've got the equator, okay? So we have moist, warm air. It's gonna rise up, okay? Things that are warmer, think about it if you live in a house that has multiple stories. Think about which story is the warmest one. We know that heat rises, okay? So yeah, the top floor, and the same thing's happening here. So this warm, moist air is rising upwards, and as it rises upward, it meets this cooler, drier air, mixes, and it begins to sink back down. And it creates this whole entire cell of warm, moist air rising, mixing with that cooler, dry, dropping back down. And the same pattern goes up again. So as you can see, moist air, warm air rises up, mixes, gets denser, comes back down. Moist air rises up, mixes with cooler, it sinks back down. Okay, this is having an effect on these currents, creating the winds to move in certain patterns. You can see here, you can see some of the wind currents. So there's actually like currents of wind. They have names like the trade winds right above the equator, as you can see, the westerlies and the polar easterlies. And again, this is describing the ways in which the wind is moving. Okay, so then we talked about this high and low pressure. And what does that have to do with it? You always see it on the weather forecast. They're like, oh, high pressure's building. Yay, pleasant day, huh? So with high pressure, it's caused by a downward moving air. As the air is forced downward, its pressure increases. It's like you're pushing a balloon. You're pushing a balloon down, creating more pressure. Okay, its pressure increases as it gets closer and closer to the surface of the Earth because the pressure decreases as you go up in the atmosphere. So why does that matter? As air moves downwards, it's warm and it dries out significantly. Okay, so as the air is being pressurized down, it moves downward, it warms, and it dries out. So with a high pressure, we're going to get those warmer, clear, drier days. Low pressure, on the other hand, is caused by an upward moving of air. As that air is forced upward, it cools to its dew point, forming condensation. Think about that water cycle. All that water vapor is condensing together, creating those little droplets, and it causes rain. Typical horizontal airflow at the surface around the low pressure is slightly inward towards the center. The inward moving air around the surface causes air to converge or come together. Since the converging air cannot move downwards because the surface is blocking it, it has to move upward, leading to that condensation and therefore precipitation or a rainy day. Let's look at another picture of that. Okay, so looking at these key points here, thinking of a low pressure, okay, air cools as it rises, causing water vapor to condense. Okay, so all of the moisture in the atmosphere, in that air, that particular area is going to condense together. As those water molecules condense together, we get condensation, more and more condensation then produces precipitation. Air it's blocked from moving downward, so it pressurizes together, and that's how we get all of that condensation and precipitation to start. Okay, so it causes that cloudy precipitation. Now, with a high pressure, we get sinking air, and as it warms and as it comes down, it warms up and it spreads out. And as it spreads, it dries out because it's got space to spread apart. Okay, so we get warmer, clear days. Okay, those are the big parts there. Let's kind of go over a couple of the questions that we see that come from that unit. Pressure generally brings fair skies and no precipitation, a nice day. Would you say that's variable, low, cold, or high? You can talk out loud, or of course you can use that chat, as I see some typing going away now. That's right, it is D. A high pressure is going to bring fair skies and no precipitation, a nice day. So again, as that air is getting pushed downward, it dries out, it spreads and warms. Low pressure means falling pressure. And that is true. Due to blank, we get high or low pressure systems. Is that due to the atmosphere, air currents, rain, or water currents? That is B, air currents. So how the movement of the air can create high or low pressures, depending on if it's being pushed upwards or pushed downwards in temperature. The Earth's rotation causes wind currents to circulate in certain ways. This is called the Coriolis Effect, the climate effect, the jet effect, the rain shadow effect. You're right. That is A, the Coriolis Effect. Air currents move in the same direction in both hemispheres. True or false? Yep, as we saw, that is false. We know that they are opposite of each other. And so as we think about seasons, the northern hemisphere and the southern hemisphere have opposite seasons from each other. So when it's winter in the northern hemisphere, summer in the southern hemisphere. Okay. We also know that they move in opposite directions. Northern hemisphere is going to move clockwise, and southern hemisphere is going to move counterclockwise. And so people talk about when you flush a toilet. Yes, it's true. The way that the water moves is opposite in each hemisphere. Okay, that's the first part on weather. Does anybody have any questions about weather or any questions about a particular topic or an assignment? I'm going to pause here for a moment to make sure that you should get your thoughts across. I'll give you a little bit of time. As we think about these live sessions, just because we're talking about earth science doesn't mean that you can't ask a question about biology or another course that you may be taking. It is open for whatever. And I always like to encourage, if you have an idea for a topic for a live session, there's something that you'd like to go over, see a little bit more information on, or a skill, there's something technology-wise that you're having some issue with, I would appreciate. I'd love to get that feedback from you and set up a live session. You can let me know. You can let me know here today. You can chat me. You can send me a message online. You can send me an email, whatever works. Here to help you guys. Okay, well, we'll have one more period for questions at the end. So let's move on to our next little section here. And let's go to a little skill. So how do you download and upload a document? Okay, and sometimes we're like, oh, we know how to do that. You just click on it, save it, all that good stuff. But we also know that in some of the courses, it's built into the course. And so it might be a little bit different than what we're used to. So I want to take a look at that. Okay, so in the Coriolis Effect, let's see. So this is activity 521, the Coriolis Effect. Okay, it gives you the directions for this assignment, and so you'll notice that if there is some type of an attachment that goes along with the lesson, you'll see it with that little paper clip. Okay, and you just click on that, and it'll just download. And then when we talk about the Dropbox, so the two things that you need, of course, is the attachment. Okay, so again, that paperclip represents the attachment. And then you've got this Dropbox. And the Dropbox is going to be where you submit the file that you want to send in for your assignment. Okay, so we'll come back to that in a second. Let me show you a couple more examples here. Okay, so this comes from a marine biology course where it has the same thing, is they have to, in this particular activity, ask them to write a paper. And so this one, they're writing a report, and then they have to submit it through the Dropbox. So Again, sometimes you'll see them, the attachment could be right up here at the top. And then of course that Dropbox is usually always towards the right-hand side down at the bottom in that blue box. So that is going to be where you're going to want to click and then attach your document there. Okay, so let's go back up here to this one. The Coriolis effect. For this assignment, you'll select the Coriolis effect on a map of Earth and describe the impacts of this movement. Use the document attached to complete your assignment. Follow the directions below. Okay, so here's, of course, the document. And what they want you to do is label the equator, and then they want you to select the arrows that indicate which way the winds blow in both the northern and the southern hemisphere, and then explain in your own words how the Coriolis effects impacts your life here on Earth, and then submit it into the Dropbox. Okay, so when we click on this, okay, what it's going to do is it's going to ask us what we want to do with that. And so we're going to want to save it because we want to be able to find this on our computer. We want to be able to edit it, meaning put in our responses, and then we want to be able to find it. So as you open it up, you're going to want to go to, your file, your save as. Okay. And then you can name it, of course, wherever it is that you want to name it. I just kept it with the name of the assignment, or Science Coriolis Effect. It comes from Unit 5. And then you also want to think about, if you don't already have this set up, I know this happens to me all the time. I'm like, where did I put that document? Make sure where you're thinking of where you want it to go. Where is it in the correct folder, or on this particular one, I have it going to my desktop so that I can access it quickly and easy. Okay, so make sure that you know where your documents are going when you save them. Okay, and then you would click the save. Okay, so then from here, you can then go ahead and edit this document. You can go through the questions and then save it and upload it. Okay, so let's see. This one goes back to this is the example in the marine biology. So if you click on that Dropbox, when you open up that Dropbox, it looks like this. Okay, and so then this is where it's going to ask you to, you can, this is where you're going to add your attachment. If you already have the document complete, you can just choose the document or choose the file, either one of those, depending on what type of a document it is that you created, and then attach it. You have a space in there that you can write in any notes that you want your teacher will see, and then you're going to save and, of course, submit. Okay, so it'll save it when you attach it, and then the last thing you need to do is submit that. So you got to do a double two-step in some of these. Okay, does anybody have any questions about that? Let's go ahead and take a look. Let me pull up the Earth Science. Okay, so you should be seeing on my screen, and I know that this is coming from it. This is a teacher view, so it might look a little bit different, but I'm going to go into the lesson. Okay, so this is what you should see. So again, here's our assignment. We'll see our Dropbox down here, and of course we've got our attachment up here. So if you click on that attachment, here we've got it. Click on that. It comes down to the bottom down here, down on your bar. Open that up. It's opening very slowly. There it is. Okay, now from here again, this is the blank document. So what we want to make sure is, because I've seen this lots of times where I get a blank document, and so it looks like it must have got opened, worked on, but it was never saved. And so then when it was added to the Dropbox, it was just the original directions. Okay, so here are the directions, and the first thing we want to do, of course, is to save that. So we go to that file and save as. Before you do anything else, let's save this, okay? So again, here we have the name of it. Where is it going? So as you can see, that goes to my downloads. For me, that one doesn't work for me because I'm like, where are my downloads? I want to have it nice and easy, so I always put it on my desktop. For me, you might have it set up. I've seen lots of students set it up kind of by folders, and so they have a folder for each one of their classes, which is great. So then you can keep it separated by, you know, if you're taking an earth science class and then maybe a math class. Okay, and then click save. Okay, so now this is saved onto your laptop or your computer, whatever it is that you're using, okay? So it's there for you now, okay? And now you can go ahead and start working on it. So as you go through, replicate what you saw in the video and the lesson by answering a few questions about the Earth diagram. Your goal is to illustrate the way winds circulate across the Earth. So first question, select the line that represents the equator on the map of Earth. Because it's a good reference point for this activity, is it line A, B, or C? You've got it, that is B. So all they want you to do is put in B for the equator. And again, we use this as a line of reference to show the northern and the southern hemisphere because we know that Earth is sitting on that tilt. It's causing one hemisphere to get more of the direct sunlight, direct rays from the sun. Okay, then we go revert to the directional arrows for questions 2 and 3. What direction do winds move in the northern hemisphere? Type in the arrow number below. Do they move up to the right or do they move up to the left? Remember, counterclockwise or clockwise? That's right. Arrow 1. Okay. In the northern hemisphere, our winds move upwards towards the right in a clockwise position. What direction do the winds move in the southern hemisphere? Type in the arrow number below. Yep, they move downward and to the left, counterclockwise. So that would be arrow 3. In the space below, explain in your own words how the Coriolis effect impacts your life or the life here on Earth. And as we talked about it, what's that effect? Because of the Coriolis effects, we get changes in the air currents, which has an effect on the weather. So in here, you could say the Coriolis effect affects me personally and the rest of the Earth. I will just say, and life, by directing air currents, which affects weather patterns. Okay, you could type in here where I live in the northern hemisphere. In the northern hemisphere, weather patterns move in a clockwise pattern because I live in the northern hemisphere. Okay, so in there we explain how it affects life on Earth, of course, by affecting the way that the air currents move, which affects the weather that we get. Okay, when you have completed your assignment, when you're all done, you want to make sure that you save. Okay, so now we've saved, you know, the work that we did on this assignment, and then we're going to want to go to our Dropbox. Okay, and you're going to want to, I can't, I'm enrolled right now. I'm doing this as a teacher, so it won't show me a student view. But in here, you're going to click add that folder. There will be a little bar that says to click on the folder, and you're going to click on your folder, save it, and then submit. And that's how you complete with the Dropbox. Okay. Let's go back here to the PowerPoint. Okay. So that kind of gives you an idea on how to complete 521 Coriolis Effect, how to upload and download that document. We're going to go ahead and open it back up for any questions that you might have again. This will be our last little section here in this live session. So make sure if you have any questions that you get those out. Okay, as I'm waiting for questions to come in, if you have any, again, you can type it in, you can just take yourself off mute. Thinking ahead, okay, guys, if you have questions during the week as you're going through your courses and you're going through concepts and activities, and if you have, if you're stuck on something, please don't get to that frustration period. It's really easy. Just send a quick chat message or an email, whatever your preferred mode of communication is to your teacher, okay? We're here to help support you guys. And so you don't have to wait until these live sessions if you have a question. What's nice about the live sessions, it is kind of like a set up time that you can get that help. And we can also show you things. It's a nice way because we're already in this meeting where I can screen share with you. That it's easy to show you some different resources. But that doesn't mean that you can't throughout the whole entire week just ask questions if you have any questions about it, about work that you might be working on. Okay. I always feel like sometimes just having somebody else explain an idea or directions in just a different way. They just change the word instead of reading it, having somebody say it to you can make all the difference and make that aha, that click work for you. Okay, so again, as we're thinking about, we're here to help you guys. We're here to help you succeed through these courses. So please never feel shy about sending us questions. That's what we want to get you to succeed in these courses and get you done and passed and through them and earning your credit. Okay. And as we think about next week, again, I'll be on next week as well with the live session. If you have an idea for a topic, please let me know. I'd love that feedback. I'd love to get an idea on what might be helpful to you guys. Also, you can think about the next live session. If you have questions, always bring your questions prepared, ready to go. Okay. Okay, if we don't have any questions, then we're going to go ahead and sign off. I know that there's another session coming up right after this, but thanks for joining. I hope this was a little bit more informative and helpful for you with the weather pattern and Coriolis Effect. And so moving forward, thinking about uploading and downloading those documents if you have that Dropbox that you can use. This is a great resource. Just always make sure that you save your work, please. I always say that when you can't find it. So first thing is always to save it to your computer so that you know that it's there, name it, make sure it's in a place where you can find it, and then start working on it, and always make sure that you save your work as you go through, okay? So that then when you do go to upload it, it is right there, okay? Okay, guys, moving ahead as you start thinking and looking outside and that weather right now, think about what we talked about today and how this is happening. So again, as we think about weather is what's happening. It's the current state of the atmosphere at a particular place in a particular time, and it can change hourly, it can change daily. And of course, we know that weather is different all over the earth. So we're talking about that particular place. Whereas when we're thinking about climate, it's more of that average. It's the weather patterns over longer periods of time. Okay. Okay, guys, have a great day. Keep up the good work in science, and we'll see you guys later.